Hey everybody, we'll wait a couple minutes for everyone to sign on here. Sorry for Mariana.
Good.
Okay, so just kind of keeping an eye on our calendar coming up here. I'm going to go ahead and screen share the syllabus so that we can all make sure we're on the same page here. So today we're starting states of consciousness. So you'll have your next explain it to the media quiz. I'm kind of killing a couple minutes so more people can sign on here. And so your Learn Smart modules due today, and then the Connect assignments are due the last day we cover it. And that's how it's always supposed to have been, but I've been messing with deadlines so that people can try to catch up. I know a couple of you are still trying to catch up. I'm seeing your emails. I'm not always getting a chance to answer them because I had another class until about 15 minutes ago, but it's fine. Essentially, it's largely going to be fine. So you can just sort of make that assumption. Jacob, I'm going to write back to you in the chat real quick. Okay. So then we'll cover learning. And then in a couple weeks, you'll have exam 2, and that will cover sensation and perception, states of consciousness, and learning. Okay, so just sort of keep all that in the back of your mind. We should be having research opportunities coming up pretty soon from our senior students. And actually my lab should have a couple coming up as well. So those will be coming up. Yeah, and just make sure you're keeping on top of things on the syllabus with what's there. I know at least one person has messaged me and said that they can't hear me today, probably because of everything going on campus. So I'm going to type the info for the quiz in your chat box here. So you're going to go to Blackboard, to our page, exams, quizzes. And then it is the explain it to the media quiz 5. Should be the only thing available. So go ahead and take that as per usual. I'll give you to about 120 or so. If you have any questions, type them in the chat to try to minimize distractions for the people who are in the process of taking it. Okie dokie. So if you're not entirely done, you can just keep wrapping up as we start talking. And apologies if you are having trouble hearing or seeing me. Apparently, a couple of people are because of the internet issues. So I am going to talk like normal, and it is going to record, and I'll put it on YouTube so it can close caption, all that good stuff. So yes, if you got in late and you haven't done the Explain It to the Media quiz yet, feel free to go ahead and do it on Blackboard. Should be the only thing under exams quizzes right now. Alrighty, so I'm going to share my screen. And today we are starting to talk about states of consciousness. I'm going to go ahead and get everything set up and rolling here. Literally rolling, in the case of getting my chair out of the way here. Sorry, that was cheesy, I know. But starting states of consciousness today. This is a really fun chapter. We talk about things like sleep and other things along those lines. So lots of cool stuff, extension of our sensation and perception, and other chapters as well. While we're taking your quiz, I got a quick visitor, and so I thought you all would enjoy seeing the photo I was able to snap here. Oops. Go back on here. So Simba was demonstrating states of consciousness for us. Sweet boy. He's back on the chair now. He's not being very polite with where he's looking right now, so I'll stay blocking him for a minute, but he is a cat. So, but I just thought it was really funny that he decided to demonstrate for us today. So we're going to talk about the nature of consciousness during this chapter. So we're going to start by talking about what is consciousness? Like, and use the chat like we usually do here. How do you know when you're conscious? Right? How do you know you're conscious right now?
We're awake.
Okay, yeah, awake. That's good. Hopefully alert. Right, being aware of what you're doing. Yeah, that's good. Yeah. So awareness is a big piece of it, right? So awareness of external events, but also of internal sensations. So external events, internal sensations. Parts of your brain that are involved in awareness include your prefrontal cortex, that good part right behind our foreheads we keep referring back to, the anterior cingulate, and the association areas. Awareness is really a subjective state of being conscious, and it occurs in what you see labeled here as a global brain workspace, involving a variety of brain areas working in parallel. So essentially, a big part of your brain is involved in consciousness. Now, arousal is a piece of this, and this is not sexual arousal, right? This is physiological arousal, so being sort of aware and alert of what's going on around you. So this is awareness occurs under conditions of arousal. Awareness occurs under conditions of arousal. So a sleeping person is not in the same conscious state of consciousness as when they're awake, right? And arousal includes the reticular activating system, and it sort of regulates our awareness, you know, alertness versus being relaxed or drowsy, right? You might feel like you need that little extra kick of caffeine here. Now, interestingly, neuroscientists and psychologists do not believe there's a specific place in the brain for consciousness. They believe there are separate processing systems that connect to produce consciousness. So it's not like you have a consciousness moved into your brain. It all sort of interacts together. So in terms of levels of awareness, we have higher level consciousness, and this is where we can do control processing, where we are actually actively thinking about things, planning things, things along those lines. While we're in higher level consciousness, we actively focus efforts towards a goal. This requires attention, right? Which in turn obviously requires some measure of focus. Lower level consciousness involves automatic processes that require little attention or conscious effort. And they don't interfere with other ongoing activities, right? So things that just sort of happen in the back, the autonomic nervous system, breathing, digesting, things like that, right? We don't have to be like, I think right now I'll digest that piece of cheese I had at lunch, right? Our stomach just goes for it. Now, daydreaming is something that I often get asked about when I talk about this, right? So these are wandering thoughts, and they can include fantasy, imagination, rumination, which is where you just sort of like chew over one thought over and over and over and over again. And daydreaming is potentially useful. Research suggests that it might help us with problem solving, and it might also help us to remind us of things that we need to be aware of or remember to do, things along those lines. So let's think about lower level consciousness a little bit more detail here. Oh, I just realized that went over exactly what I just said out loud, so I will skip ahead to my next slide. All right, and we'll talk about altered states of consciousness. So we tend to think of altered states of consciousness mostly in terms of sleep, right? Yes, I see that Carter's writing about maladaptive daydreaming, right? So you can have daydreaming where it's a distraction, right? And in fact, that's actually part of like an ADHD diagnosis, is being essentially inattentive or daydreaming. And it's actually harder to sort of catch and diagnose those kiddos than the ones who are actively acting out, right? Definitely. All right, so in terms of altered state of consciousness, we can have drug states. So certain drugs, and drugs are not only just what we think of as like illegal drugs, right? They can include alcohol, they can include prescription drugs, right? We have an opioid problem here in the US. And these can, put us in a state of euphoria, really mellow us out. These can make us hallucinate, right? Certain drugs are hallucinogens. So that can be, obviously, that's what you're going for, great. If not, could be problematic, right? But other things we don't necessarily think about can do this to us. Fatigue. So a study came out while I was in college that said that lack of sleep, sleep deprivation, can be equivalent to the effects of alcohol on your body. And I always sort of joke that, like, I am living proof of this because I was a member of our editorial staff for our weekly student newspaper. And we would stay up all night every Wednesday trying to get it done. And like, everyone told me this story that apparently at one point I put a paper plate on my head and like danced around. I do not remember doing this to this day. I was just so tired. It was like I was drunk apparently. At least I did something that wasn't harmful to anybody else. Illness, so people that are getting COVID, people who get especially things like the flu or urinary tract infections, things that have high fevers associated with them. You can experience altered state of consciousness during those. Trauma. So when you're in the moment of a trauma, your brain essentially tries to protect you. And so it processes things in a completely different way. And then if you've experienced a trauma, you can actually find that you do something called dissociation, which is when something reminds you of the trauma, you essentially zone out and you might end up sort of back in the trauma, in the memory of the trauma, can be like a flashback. Or you could end up just sort of spacing out to protect yourself. So you're not in the moment having to think about the trauma. And it's all about your brain trying to protect you. Then any sort of deprivation, food deprivation, water deprivation, right? People can get to the point where they're hallucinating or have other altered states of consciousness at that point. There are times that we do this on purpose. So meditation is something that tries to put us in this state. So if you've ever used sort of those Headspace or other little apps that help you meditate along these lines, even something like yoga, right, can put you in an altered state of consciousness. Hypnosis, yes, yoga is a very good coping tactic for anxiety, actually also for depression, anger management, and so are meditation and mindfulness in general. There's a lot of really cool research about this. And physical things too. So people that have heart attacks, for example, research shows that if they're introduced to meditation afterwards, their blood pressure actually drops, as well as feeling less anxious. So it actually can have physiological effects, which is very cool. Hypnosis is another piece of this. So people can undergo hypnosis therapeutically, and it purposely puts you in an altered state of consciousness where you're more receptive to the help that the therapist can offer you. Then there are mental disorders, and there are not all, but some mental disorders can alter your state of consciousness. Not only in terms of, just again, something like schizophrenia where you might hallucinate, but also there are what are called dissociative disorders where you might just sort of zone out even without a trauma. Or there's an extreme dissociative disorder called dissociative identity disorder. Used to be called multiple personality disorder, where essentially you like dissociate into different personality states. Now, in terms of levels of awareness, there is subconscious or unconscious awareness. So there's sort of incubation where something that's presented so quickly you can't actually process it. Might still sort of sit there in your mind. And then there's what's called parallel processing, which is waking subconscious awareness. So when you're awake, processes are occurring just below the surface of your awareness. You're aware of what's going on right now, but there are other things that are also going on beneath your conscious awareness. Now, interestingly, again, some people call this subconscious awareness. If we go back to Freud's theories we talked about at the beginning of the semester, he always used the term unconscious awareness, that it wasn't beneath the surface, it was like out of our awareness. So you'll hear different psychologists use different terms. Sleep and dreams, again, big part of what we're looking at. What part of the brain allows you to dream? Really all of it. Especially when you're in REM sleep, your brain waves and your brain activation looks like you're awake. So they're a really good question. The whole brain comes into play there.
Can I ask one more question?
Sure.
If dreams are a level of awareness, well, how come we rarely remember them when we wake up? Is that normal?
Yeah, well, we don't remember everything we think throughout the day or experience throughout the day either, right? So that's part of it. It's just like, what are...
We got it.
Remember? For anyone who has seen the movie Inside Out, there's the part where the little workers in the brain are getting rid of old memories, and that happens in the actual brain, right? So we decide what to hold on to and what to let go of.
Okay, because I can never remember my dreams.
Yeah.
I wake up and I forget everything.
Yeah, a lot of people will report that. And oftentimes we don't remember them unless they were sort of happening right before we woke up, and we sort of woke up out of them. And then there are some people that just remember all their dreams. And so it might be like an individual difference variable. Yeah, these are things that like, we don't necessarily know everything about, which is really cool. There's a lot to be learned here, so. Good questions. Any other questions about sleep and dreams? And like I said, we'll get a lot more into this as we go through as well. So during sleep and dreams, the level of awareness is below what experience happens during daydream. And when we are asleep, though, we're still somewhat aware of external stimuli. So this is why, like, if you have a partner and they snuggle into you while you're sleeping, even though you don't wake up, you might snuggle back into them. This is also how we can wake up if we hear something like a fire alarm, right? Because otherwise we would just sleep through it, and that could be really problematic. There are possible times where we might have no awareness. So when they're unconscious, normally knocked out by a blow or under anesthesia, then it's entirely possible you would remember absolutely nothing. Although there are certainly cases of people who've been like in a coma and wake up and say they remember people talking and what they were saying. I mentioned that Freud believed that unconscious thought is where a person keeps unacceptable wishes, feelings, and thoughts that are beyond their awareness. Sometimes this is referred to as censored thought, because again, Freud thought that we were purposely keeping it from ourselves. Sleep paralysis can happen, yeah. So that's actually a sleep disorder where you wake up in the part of sleep where everyone actually experiences parts of sleep where you can't move, but you just sleep through them. And so sleep paralysis is where you wake up during that state, and it's absolutely terrifying. And non-conscious processes can happen too. There are other parts of consciousness that are really important to consider, and those include biological rhythms. So we all have periodic physiological fluctuations, and these are controlled by biological clocks. So not the one like, my biological clock is ticking, I gotta have kids, right? But the idea is that we all have sort of internal clocks that keep things regulated. And these can be annual, they can be seasonal, they can be 24-hour cycles, and these are typically referred to as circadian rhythms, and they're monitored by the supraplasmatic nucleus in the brain. So circadian rhythms are daily behavioral or physiological cycles. So not only does this include the sleep-wake cycle, it also includes body temperature. So our body temperature fluctuates throughout the day. Blood pressure, blood sugar levels. And the changing from day to night is controlled by this nucleus in our brain. It's a small structure that synchronizes its own rhythm with the daily cycle of light and dusk, which is based on information from the retina. And this is why you're starting to see a lot of research coming out talking about how it's bad to be on your phone late at night or your laptop, because these emit a specific kind of light called blue light, and it sort of mimics sunlight in ways that are important to tell our brain not to start getting ready for sleep. So most newer phones will have a anti-blue light setting that you can either just turn on or you can set to come on as it gets later at night. There are also apps that will do that for you. And I actually attended a virtual talk, I guess, over the summer, but I listened to it live about this and about how they found this in lab animals, and it does actually seem to be related to mental as well as physical health issues. So it's actually a thing, some science behind it. Now, in terms of biological clocks, in addition to blue screens, there are other issues that can lead to desynchronizing these clocks. So one is if you travel, especially through multiple time zones, you can get what's called jet lag, where it just takes your body some time to adjust to your new daylight schedule, right? Daylight, nightlight schedule. Because it might be, 7 hours off, 12 hours off from where you were. A lot of people will say, Once you get to your destination, try to stay up until it's time to go to bed, things along those lines. Different things work for different people, honestly. Melatonin can also reverse the effects of jet lag. So we'll talk a little bit more about that as we go through things coming up here. You can also be set off by shift work. So if you sometimes work, say, 6 a.m. to 6 p.m., but then 2 days later you have to work 6 p.m. to 6 a.m., right? That's going to just mess with your biological clock and make it really difficult. Also, some people just suffer from insomnia, where they have difficulty sleeping for a whole host of different reasons. It can be related to mental health. It can be related to physical health. It can be related to things like substance use, right? And that's obviously going to mess with your biological clock as well. So one of the things that can help is, again, spending as much time as possible while it's daylight in the daylight. And then your body kind of learns the difference when it gets to be night. And then, as I mentioned, melatonin. So melatonin is actually a hormone that our body typically actually produces. It's sometimes called the Dracula hormone because it's produced in these evening hours. And it, again, typically would be produced by our bodies as it got to be time to sleep. Modern use of electric lights, blue screens, things like that, kind of messes with melatonin production in our bodies. So you can now supplement that. You can actually buy melatonin supplements and take those, and those can help you sleep. And in fact, they even make them for kiddos now, and they're melatonin gummies. So, you know, they're hopefully somewhat appealing to the kids. So now we're going to talk about a big way your biological clock can get off, and that is seasonal affective disorders. And so these are not a 24-hour cycle, but rather an annual cycle. They're more of a problem in places where it's colder or drearier in winter, so places that are further north. So people did tend to get them in the Midwest, where I'm from, and they can be more of a problem, again, in these places where it's yuckier in the winter. So what is a seasonal affective disorder? It's actually a specifier for depression or for bipolar disorder. It's not its own diagnosis. These are the criteria from the previous version of the DSM, but they didn't really change that much for the DSM-5, so we'll just roll with them. So there are usually, again, sort of, you just go through time over the year and your moods might fluctuate like normally, and you're fine. But what happens with people with this seasonal pattern specifier is that there is this temporal relationship between always getting depressed at one time of the year. So, and again, it's typically winter. It's typically, yes, Lara, anything I cover could potentially be on the upcoming test. But also a reminder to everybody that the slides are online, so you can download them and type on them or print them out for yourselves. So full remission at other times of year. So in the summer, you wouldn't experience depression. And it has to happen for at least 2 years. It can't just be like, oh, you got depressed once in the winter, right? Because there's a whole bunch of other reasons why that could have occurred, right? And that you're not getting depressed other times, because there are people who just have multiple episodes of depression, and that could, in theory, you know, again, not be seasonal, but you're having multiple episodes. It also has to be that those suppressive episodes outnumber the non-seasonal ones, the ones that are specifically tied to the season. Again, this can occur with bipolar disorders as well. And again, the time of year is typically winter, but rarely you can get other seasons. And we're going to talk about a study that's kind of old now, but Rosenthal et al. From 1984. And they noted that some patients got depressed in winter and better in the summer, or sometimes if they, again, had bipolar disorder, they would actually experience manic episodes in the summer. So this was, again, back in the day, so they couldn't like just throw a recruitment announcement on, Reddit or something, so they could put out newspaper ads. Ooh, how quaint, right? So that's how they found participants. They got 29 people that they got qualified, 25 women, 4 men. Mean age was about 36, 37. And they had them complete 2 different scales of depression, the Beck Depression Inventory, the Hamilton Rating Scale for depression, those types of details you wouldn't have to know in detail, clinical evaluations. And then what they decided to try to do is what's called light therapy. So what they did in particular was having people for 3 hours before dawn and 3 hours after dusk for 5 weeks. So 2 weeks, then 1 week off, then another 2 weeks. And they were randomly assigned to one of 2 types of treatment. So they either got a white full spectrum light or a dim yellow fluorescent. So as you can see, it wasn't nearly as bright as a sunny day, but it certainly was brighter than a fluorescent, right? So they were trying to see essentially if being exposed to this white full spectrum light would start to make them feel better. So they reassessed it after 2 weeks. So if they improved, they would wait a week and do the second type of light therapy. But if there was no improvement, they switched to the other type of therapy. Again, when you do treatment studies, you don't want to keep people depressed, right? Like you want to try and get them help as much as you can, as quickly as you can. So they had 9 participants who were able to go through the entire thing, 2 weeks of one type of therapy, week off, 2 weeks of the other type of therapy. 2 others only did the white light condition. Everybody improved with the white light. When the light was stopped, everybody felt worse to at least some extent. And 7 of them said, I'm going to keep using this even after the study. Now, when they looked at the dim yellow light, no improvement. 3 participants did feel a little bit better, and 1 said they were going to keep doing it after the study. But if they looked at it statistically, it wasn't significantly different from the people who, were experiencing no light or when they first came in. So overall, the white was better than the dim yellow light. And so this is a chart of how everybody did with the white light versus the dim yellow light. If you see here, 1, 2, 3, those are the people who actually did better with the dim yellow light. But you can see that like just about everybody else stayed the same or maybe even got a little worse when they were using the dim yellow light, whereas everyone with the white light improved at least a little bit. And so this is their rating on the Hamilton Depression Scale. So higher scores means higher depressive symptoms. So, hey, the light is actually seeming to help people. So the light box seems to be the treatment of choice. There are also light visors and dawn simulators, and now there are like these fancy alarms that wake you up with sounds and ambient light. They're less researched, but the light box really does seem to work and is the treatment of choice for seasonal affective disorder. So usually you have people do it for 30 minutes plus. You don't need UV, it's just this white broad spectrum light. You have people use it every day. It doesn't have to be the hours before and after dawn and dusk like it was in the study. The patient can just find the time that works best for them. And it works quickly, within 2 to 4 days. And that actually tends to be faster than talk therapy, faster than medications. Antidepressant medications could take 2 to 4 weeks to kick in. So this is a really quick and effective and often fairly cost-effective way to treat this, right? The only problem is if you stop using the light, your symptoms come back pretty quickly. But the other sort of other side to that is there are very few side effects. The quick response is nice. Also, the patient can sort of figure out which type of light works best for them. The only side effects people experience occasionally are headache and eye strain. And again, if they sort of work on the angle, that typically helps. Sometimes they'll just feel wired, like it wakes them up so much, right? It's like they drink a lot of coffee. And they also think this type of light therapy might work for people who, might not meet criteria for a seasonal affective disorder, but just kind of get the winter blahs. And so, again, we have some really nice research to back this up, and I can provide you an anecdote to supplement that. We always want to look at the research, right? But then it's helpful to hear about, sort of the application. So in graduate school, one of my classmates was a very brilliant woman. She's now a neuropsychologist, but she's from the Philippines, and she went to grad school with me in Ohio. And so she actually, again, very well-functioning individual, very brilliant, but she developed seasonal affective disorder. And she had never experienced these blah winters before. And she got one of these lights, and she said, she's like, I should just believe it from the research, but now I've experienced it myself, and it really does make a difference. So, again, sometimes the simplest things are the answers. We don't need to do really complicated talk therapy or do a whole bunch of cocktail of medications, right? It can be as simple as, let's put a light on and help the person feel better. Alrighty, so now we are going to start talking about sleep. And we're going to talk quite a lot about sleep. So, I'm kind of flipping through my notes here, and I think we talk about sleep for like this long in my notes, so it's like 4 or 5 pages of notes. So we'll be talking about sleep for a while. So why do we even bother sleeping? It seems kind of like wasted time, right? We could be using those 4 to 8 or sometimes 12 hours, right? Well, there's an adaptive evolutionary function in terms of safety and energy conservation and efficiency. So many of the body's cells show increased production and reduced breakdown of proteins during deep sleep, especially. Sleep also gives the neurons used while awake a time to sort of shut down and repair themselves. So it seems that there is sort of this period where the body is like, time to do the repairs. I don't know if anyone's ever worked at a department store where they do most of their stocking overnight, right? It's kind of like that. Like, oh, let's bring out the new shirts, put them on the racks, right? Kind of same thing. For some animals, it's safer to search for food and water when it's dark outside. For other animals, however, that doing the sleep during the dark time allows them to avoid getting eaten or fall off a cliff they can't see, right? Regardless of when they sleep, either people or animals, sleep is a time to save energy. And as we'll talk about throughout this chapter, rapid eye movement, or REM sleep, is related to the formation of emotional memories in humans. So some of our most important memories. So again, there seems to be this restorative function of body rejuvenation and growth. Sleep also seems to be related to brain plasticity. It enhances synaptic connections and may be involved in memory consolidation. So sort of gives us time to consolidate everything we learned throughout the day. This is one of many, many reasons why you've often heard teachers or professors say that you should make sure that you get enough sleep the day before an exam. Yeah, Lara, you have your hand up. Go ahead.
What about animals that have to keep moving in order to breathe, like sharks? How do they sleep?
Good question. So weird commentary on this. So my daughter is enamored of little nature videos, especially ones about the ocean. I think because we live near the ocean. So we've been watching this old show called Jonathan Bird's Blue World. One of the things that he did in an episode was go to find these caves where sharks will actually sleep, but they only do it during times that the current's really moving, because the current then can keep it over their gills. I was going to say lungs, but it's gills. The other thing that can happen is some fish and sea mammals, like dolphins, only half their brain sleeps at once. So they can kind of keep moving with the other half. So again, not something we humans are capable of doing, and kind of hard for us humans to even understand, right? But yeah, there are adaptive ways where those species can still get rest in ways that allow them obviously to keep breathing. So really good question. And obviously, if you're an underwater mammal, then you're a voluntary breather, right? So you've got to stay awake so you can go up every so often and get a breath, at least with half your brain. All right, so how do we study sleep? Well, there are a bunch of cool instruments that we can use to do this. And if anyone's ever had a sleep study done for diagnostic purposes, some of these might be familiar to you. So we have the electroencephalograph, or EEG, and this records brain electrical activity. So it's essentially the amount of activity going on in our brain. It doesn't map on to where in our brain per se it's happening. It's just sort of like overall. It's not like a brain scan where we can be like, ooh, the prefrontal cortex is lining up. There's also the electromyograph, and this looks at muscle activity. So there are different parts of sleep, as we mentioned. We might experience sleep paralysis and you don't move. In other parts of sleep, you might move with your dreams. If anyone's ever watched a dog who's having a dream, right? They might kind of twitch and it almost looks like they're trying to run after a rabbit or something. And then there is the electrooculograph, and that does eye movements. So eye movements are a really important part of that rapid eye movement sleep, not surprisingly. So it's important to document those when you're doing this type of research. They'll also observe other bodily functions. So most sleep studies, for example, they'll have like a oximeter on them to check oxygen levels. They'll have like a band to check breathing rate, things along those lines. Oftentimes, if you go for one of these studies, they might be testing you for something like sleep apnea, where you actually stop breathing while you're sleeping. So they're going to be monitoring things like that. Carter, good question. So sleep paralysis typically happens when you wake up at the wrong part of sleep, essentially. So everyone experiences sleep paralysis while they sleep. We just usually sleep through it, and then it's no big deal, right? But if you wake up in the midst of that, it's terrifying, right? So your body is in this state where you can't move stuff, right? It's just part of the sleep process. And again, we usually just sleep through it, no big deal. But if you wake up then, terrifying. So we'll definitely talk about that. We'll probably get to that Wednesday. Good question, Paul. All right, so the EEG, or electroencephalograph, it's sort of a physiological index of consciousness. And here you can see a medical professional putting one on someone. And so it can be stuck onto you like this. I've also seen ones that are like caps you put on, although those probably have less efficient conductivity. So it measures brain electrical activity across large areas of the cerebral cortex. It's basically measuring brain waves. So it's a physiological index of consciousness. And so it looks at things like the amplitude of brain waves, so the height of the wave, and then the frequency, which is the number of cycles per second. And so here you can see we'll have beta waves, don't always necessarily happen during sleep, which are sort of our fastest frequency, alpha, theta, and delta, much slower, right? Slower waves. And here is a table illustrating those types of waves and the typical states of consciousness you experience when your brain is having those types of waves. So beta waves are typically when you're awake, you're thinking, you're alert, you're problem solving, things along those lines. Alpha waves are deep relaxation. Maybe if you're doing meditation or your mind's kind of blank. Alpha waves in terms of the sleep cycle happen sort of right before you fall asleep. Theta waves are that light sleep. And then delta are where you're in that really deep sleep. Now, there are different stages of sleep. And one thing I should say is that this is one representation of the stages of sleep. I've also seen one where stages 3 and 4 are just combined. And they say there's 4 stages of sleep. So again, we're very different in terms of things in psychology. So in general, just sort of know the order these go in and focus on that as you study and learn. So these are based on physiological readings from those instruments we just talked about. So stage 1 is this brief transitional stage of light sleep. It's very short, 1 to 7 minutes. So it's right when we fall asleep, especially. The EEG starts to move from the alpha waves to more of the theta type of waves. Sometimes what are called hypnic jerks, those brief muscle contractions that occur when you're falling asleep, happen here. So this, if you're not quite asleep, you might experience this as a sensation that you're falling and suddenly catch yourself. REM sleep could have to do with sleepwalking. Yeah, really good question, Carter. Yeah. Weirdly, with some of these sleep dysfunctions, we still don't have really good answers, and sleepwalking is one of those. As to like why that really happens, there are different theories. When you are in stage 1 sleep, your breathing and your heart rate slow down, your muscle tension starts to decline, and your body temperature starts to decline. So when we're sleeping, our body temperature actually goes down. Obviously to a safe, healthy level, but essentially cools us down overnight. Also doesn't use as much energy to keep us as warm. Stage 2 is characterized by more mixed brainwave activity with brief bursts of high frequency brainwaves, and these are called sleep spindles. And so this is like 10 to 25 minutes. And again, wave, sleep spindle. Okay, and then stages 3 and 4, this slow wave sleep. It takes about 30 minutes to reach stage 4, and usually people stay there another 30 minutes. Then the cycle reverses, and so it feels like maybe we should go back to stage 2, right, or work to stage 1. Something interesting happens. That's when REM sleep begins. So, what? You want to come say hi? You already demonstrated. Here, Simba. Hey, bud. Come on. Here. Come on here. So REM sleep, again, this rapid eye movement sleep, is really interesting because on the EEG, it's similar to when you're awake. It's not quite the beta waves, but it's certainly similar. And this is where you have the really vivid dreaming. First for a few minutes, then longer. You go through these sleep cycles multiple times throughout the night. Okay, and with each one, the REM sleep tends to get a little bit longer. Again, the EEG looks awake and alert, and your eyes rapidly move behind the lids. Often you have an irregular pulse and breathing rate, and a loss of muscle tone. If you're awakened while you're in REM sleep, you report vivid dreams. So this is the stage that if you wake up, you're more likely to remember your dreams because you were just in the midst of them. Interestingly, infants spend much more time in REM sleep than do adults. During adulthood, sleep changes continue with the percentage of slow wave sleep declining and the percentage of time spent in stage 1 sleep increasing. So REM is when most dreaming occurs. And again, REM is where that sleep paralysis can happen. So again, if you wake up in the wrong part of REM, this is where you can just feel like you can't move. So here is what an EEG output would look like during sleep. So you see at the top, here are those awake beta waves. Then in stage 1, you start to see the alpha waves, the relaxation. You're getting into the theta, the light sleep, the breathing, the heart rate slowing, reduced muscle tone, the body temperature going down. You get to the delta waves in the deep sleep. So here, that's when you're all the way to the delta waves. And here in stage 2, that's a sleep spindle, that little. And then during REM, you get the, again, looks almost like when you're awake, but a little more irregular, essentially. And again, eye movement, muscle paralysis, irregular pulse and breathing, dreaming. And the average time for most people to fall asleep is about 25 minutes. Now, again, if you suffer from insomnia, that might take you much longer. If you are especially tired, it might be much shorter, right? Here's a diagram to walk you through those stages of the sleep cycle. So again, here's where you're like awake and alert with the betas, and then you start to get drowsy, you have the alphas, okay? NREM here means non-REM. Basically, they've just distinguished between REM and non-REM sleep. So then you've got a mixture of alpha and theta. Stage 2, again, here's you're getting those sleep spindles and K complexes, theta brainwaves, starting to get into delta. Stage 3 is those delta and thetas. Again, some people say stage 3 is not a thing anymore. Again, just depends on what book or article you read. Regardless, there is a stage of deep sleep, delta brainwaves, and then you go up to REM sleep afterwards. So fast active brainwaves accompanied by these rapid eye movements. And you can see how long this process takes. And again, you start with relatively short bouts of REM throughout your sleep, and then those get longer throughout the night. And that's actually what this chart demonstrates. And so I think this one's really helpful because as you can see, it's not that this happens once while you're asleep, right? So you actually see that you start and then you go into REM and then you go down again and then you go into REM. And as you can see, most dreams are concentrated during REM, and we used to think you only dreamed during REM. But in fact, they're finding more and more, you can kind of dream at any stage of sleep. It's just we have the most vivid dreams during REM. And then here you can see the last REM period of the night has the fastest eye movements and maybe the period in which dreams are best remembered. It can also be sort of the recency effect, right? You wake up and that's what just happened. And here again, you can see the eye movements tend to happen during that REM sleep. And again, I like that. Yeah, you might just be kind of rolling all over the place, except when you're in REM, then you're not moving, right? I love this depiction of it because it really shows it's not a one-time thing like we kind of think about as we look at the initial description of these things. And so again, here you can see REM, more dreams, more rapid eye movements, starts short, gets longer throughout the night, right? Until we wake up. And again, we might wake up out of REM or we might wake up out of a different stage of sleep. And so the patterns repeat throughout the night, but no matter when in the night the REM sleep is, it's high levels of physiological arousal, frequent, vivid dreams. And so throughout the night, we dream most often during REM sleep again, when activity in many brain areas is the highest. But as you can see, lots of different brain areas are active during REM sleep. And these patterns can, sorry, that was something I already said. So you can see higher reasoning is inactive, so that very prefrontal cortex, not as much. But you've got attention, complex visual processing, motivation, emotion, memory formation, arousal, physiological arousal, again, remember. And this is the brainstem, so it's always going to be active, right? So you can breathe and things like that. Very important. So this is what we see in the brain when people are dreaming. Very interesting. All right, I think I'm going to stop there because that's a really nice breaking point, and just a couple minutes early here, and we'll pick up by talking about circadian rhythms and the 24-hour cycle on Wednesday. Be talking about various types of dreams and sleep. There we go. Alrighty, so everybody have a good day. And I will do my typical stay around for a couple of minutes in case anyone has any questions.
Hi, I have a thing to say.
Sure.
Okay.